Okay, so hello guys. Um, I am going to help you to revise to prepare for your coming exam this Tuesday. So I have selected a few topics for you to focus on so that you won't be too stressed to think about what topic to study because we've been doing some topic revision before this. So this one we haven't been able to discuss. So I have selected this topic from the physics module of JPN Sabah. So you can refer this and hopefully it will help you to better understand and help you to answer the questions later. All right. So we will begin. So this is taken from chapter 6 nuclear physics in form 5 lah. Okay, so I will be discussing types of questions involving making decision and also problem solving for nuclear physics. Okay, so this is the second last chapter in physics form 5, so I hope that you can understand well. If you have any questions, please do not hesitate to ask me. Okay, all right, so we will begin. So question in section A, this is for making decision. So as you can see here, the important thing is as you read the questions, you underline or you highlight the keyword in each of the questions. This is to help you to focus on and how to answer the question well. Okay, so number 1, diagram 1 shows a system used in a factory to ensure the thickness of a cardboard sheet is uniform. All right, the radioactive source, radiation detector, and counter are used to detect the thickness of the cardboard sheet. The radioactive source contains a radioisotope. The roller is used to compress the cardboard sheet. So table 1 shows 4 radioisotopes with their respective properties. So as you can see in table 1, it has 3 characteristics. Okay, it has half-life, type of radiation, and also physical state. So you are required to choose which one is the best choice. To help you, this is to detect the thickness of the cardboard sheet. Okay, the main purpose of your choice is it should be able to detect the thickness of the cardboard sheet. All right, so you have to think about the characteristics of the radioisotope that you will be using. Okay, so next, what is the meaning of radioisotope? What is the meaning of radioisotope? So actually, radioisotope, it is not mentioned in your textbook, in physics form 5 textbook, but you have learned this previously in science form 3. So that's why if you think that you haven't learned this and it is not found in your physics form 4 or physics form 5 textbook, it is because you have been taught about this in science lower form. So whatever that you have learned in your lower form, in science lower form, you will use again that knowledge to answer the questions for physics form 4 and form 5. All right, so that's why you have to revise back. You take out your science lower form revision book again, and then you search for all the parts involving physics, because later on it will be asked again for SPM. Okay, so what is the meaning of radioisotope? It is, so you can write down the definition as unstable isotope tends to decay and release radioactive ray. Okay, so that is a short answer lah. Unstable isotope that tends to decay and release radioactive ray. Okay, next one. Based on table 1, state the suitable properties of the radioisotope to detect the thickness of the cardboard sheet. Give reason for the suitability of the properties. So firstly, half-life. So half-life, if we refer back to the table 1, it is given in numbers, okay? It is given in numbers, but in your answers, you cannot write the numbers as your answers. You should write either long half-life or short half-life. Don't write the numbers, okay? Don't write the numbers as your answer. Only write in general. So it's either long half-life or short half-life. So in this case, the half-life should be long. So as you can see here, you can choose which one is the longest half-life. So you can tick this one and also this one, okay? So if you have chosen long half-life as your answer, so you can terminate this choice, all right? You can terminate that choice. And what is the reason for you to choose long half-life? It is because you don't need to change it frequently, okay? No need to replace frequently. Or you can also write down your answers as save costs, okay? But only write one answer only, the one that you are really confident with. Do not write more than one answer. If you write more than one answer, make sure both of your answers or all of your answers are correct. If you write one answer correct and the other one wrong, so you will be, it will be wrong, cancel, right, and you will get 0 marks for that one. All right. Okay, next one, type of radiation and the reason. So back to table 1. Type of radiation that we will be using is, because we are going to detect the thickness of the cardboard sheet, okay? So it would be better if we use gamma. Beta is okay, it can still penetrate the paper, but if the thickness of the paper, the roll of paper is too thick, I'm afraid that beta radiation will not be able to penetrate through. So the best one is gamma. Okay, the best one is gamma ray. Beta, we will eliminate that choice. And then what is the reason why we choose gamma ray as the type of radiation? Because of the high penetration power. Okay, gamma radiation. And the reason is because of its high penetration power. Okay, the third characteristics would be the physical state. The physical state of that radioisotope and the reason. Okay, so back to table 1. So you have either liquid or solid. But since we have chosen, there's a clue there already. We have long half-life and gamma radiation. So better if we choose in solid form. Okay, in solid form. Why should we use or choose solid form? Because it is easier to handle. Okay, easier to handle. Solid because it is easy to handle. Because if you use liquid, the radioisotope in the form of a liquid, it will, there is a chance that it will spill. And if it spill, then you will be exposed to the dangers of the radiation. So better if you use in solid form because it is easier to handle. Okay, so based on answers in 1B, determine the most suitable radioisotope in table 1 used to detect the thickness of the cardboard sheet. So the answer based on all your choices would be cobalt 60. Okay, cobalt 60. So that's the answers. Okay, D. And then the type of radiation emitted by radioisotope in 1C has many functions in various fields because its characteristics. State one characteristic of this radiation emitted by this radioisotope. Okay, so one of the characteristics of this radiation emitted by this radioisotope is because of its high frequency. High frequency. So you can write down the answer as high frequency or no mass because gamma radiation. Okay, gamma radiation, it has high frequency. I put this one first. Gamma radiation, it has high frequency, no mass, and there's no charge. It is neutral, high energy because of high frequency. Okay, any one answer. Okay, so that is for question 1. Now we move on to question 2. In question 2, diagram 2 shows a nuclear reactor using nuclear fission to produce energy. Nuclear fission. Nuclear fission, or in BM is pembelahan nukleus. Okay, so this is the nuclear reactor. This can be found in your physics form 5 textbook. Okay, you can refer back to your textbook in page 216 for the nuclear reactor. Read that one back again, okay, in page 216. So what is the meaning of nuclear fission? So the meaning of nuclear fission would be, it is the splitting of a heavy nucleus into two lighter nuclei. Okay, the splitting of a heavy nucleus into two lighter nuclei. And then state the energy changes in the nuclear reactor. So the energy changes because it is in the nuclear reactor. So it will start from nuclear energy. This one you have learned also in science form 3. Okay, nuclear energy converted into heat energy. And from that heat energy, it will turn the turbine. So when the turbine is turned, means that there is a conversion from the heat energy into kinetic energy. And then from that kinetic energy, when the turbine is turned, okay, it will spin, and then as it spins, it will cut the magnetic field lines, and induced current will be produced. So that induced current will go to the generator, and it will turn into electrical energy. Okay. Lastly, it will be converted into electrical energy from the induced current. All right. Next. So in table 2, okay, table 2 shows 4 types of nuclear reactor, P, Q, R, and S. So again, there are three characteristics: material for the control rod, type for the coolant, and the thickness of the concrete shield in meter. Okay. So firstly, material for the control rod. So if you refer back to your textbook, page 216 in Physics Form 5, the control rod, as you can see here, control rod made of boron or cadmium. Okay, and then the function of the control rod is to absorb excess neutron. Absorb excess neutrons. That's why it is called as control rod, to absorb the excess neutrons. Okay, so it is either boron or cadmium, kan? Boron or cadmium. So iron and graphite you can eliminate from your choice. Next, coolant. Coolant or bahan untuk penyejuk. So usually we will use water. Okay, it is also mentioned here, water as a cooling agent. And this is to absorb heat energy from the chain reaction to generate steam. And this can also control the reactor temperature. Okay, so you choose heavy water, and then you eliminate oil. All right, and then the thickness of the concrete shield, of course, we want it to be as thick as possible. So the thickest that we can see here is either 1.5 meter or 2. This one you can eliminate. So as you can see here, your choice would be R. So write down your choices first and the reason. So the material would be boron. So it is either boron or it could also be cadmium. And the reason is to absorb the excess neutrons. Type of coolant is heavy water. Okay, type of coolant is heavy water. Reason is it is either you write high specific heat capacity, or water can absorb a large amount of heat energy with a small increase in temperature. Okay. Water have a high specific heat capacity, or it can absorb a large amount of heat energy with a small temperature increase. Okay, and then the thickness of the concrete shield, like I mentioned earlier, do not write the numbers, but you should write either thick or thin. So in this case, we write thick. And the reason is to prevent leakage of radiation from the reactor. Oh, if you write to prevent leakage of radiation, also enough. All right. So the last one would be your choice. So answer is R. Okay. So that is for question number 2. Next, we will go into in section B and C, making decision also. So this one is applied in a nuclear powered submarine. Okay, nuclear powered submarine. A nuclear powered submarine is to be built. Table 1 shows the characteristics of 4 submarine models, W, X, Y, and Z, with different specification. So usually in section B, you are given 4 characteristics. And as I have mentioned in previously, for essay questions, it is recommended that you answer in table form. Okay, 10 marks for this. So you should answer in table form. So the characteristic, the aspect, there are 4. The fuel of the nuclear reactor, the half-life of the fuel, a chemical reaction to produce gas for breathing, and also shield of nuclear reactor. Okay. So you are required to determine the most suitable nuclear powered submarine model to function for a long time. To function for a long time in the ocean and efficiently. Justify your answer. So that one is 10 marks. So please answer in table form. Okay. So table form means you have to do at least two columns. Okay, 2 columns. So your answer should be something like this one. Okay, like this. So you choose uranium-235. Okay, choose uranium-235 because it is more unstable nucleus. Unstable nucleus. Okay, it is an unstable nucleus. And then we choose long half-life. We choose long half-life so that it can be used for a long time. Okay, and then let me refer back to the table. Okay, uranium, long half-life. Okay, and then a chemical reaction to produce gas for breathing. So this one you have learned in your chemistry. We usually use water electrolysis. Water electrolysis, okay, not neutralization of acid and alkaline, because this one is quite dangerous. So better and safe if you use water electrolysis, because this one can produce oxygen gas. And then the shield of the nuclear reactor, it should be made from concrete. Okay, it should be made from concrete and not steel. Okay, so let's go back to the suggested answer. Okay, so water electrolysis, reason is oxygen gas for respiration can be produced. And then the type of shield is concrete. Reason is prevents leakage of radioactive radiation from the reactor core. And then your choice, you have already 8 marks. So the remaining 2 marks will be your choice. Okay, so you mention your choice. And lastly, you copy back what you have written in your choice. Because of the uranium-235 fuel, long half-life, electrolysis, chemical reaction, and concrete shield. All right, so this one is 1 mark. So overall, it would be 10 marks. Okay, 10 marks. Quite simple actually, this question. This chapter is not that hard. It's just that you need to do some readings for you to understand it better. Okay, don't worry too much. Okay, next question is still involves a nuclear power plant station. Okay, a new nuclear power station will be built. In the planning process for the construction of this nuclear power station, several things must be considered. Table 2 shows some characteristics to be considered as well as recommendations for each of them. So again, you will be given 4 aspects or 4 characteristics for you to choose from. So we have the location. Okay, we have the location, the material of the building, the radioactive waste management site, and also the cooling agent. So again, you answer in table form. So let's see the location. The location for the nuclear reactor, it would be better if we construct the nuclear power reactor by the sea. Okay, by the sea and not at the mountainous areas. By the sea. Why? Because it is nearer to the water sources. Water sources from the sea that will be used as the cooling agent. All right, so that is the reason. And then the material of the building, of course, it should be made from concrete and not aluminum. What is the reason why we choose concrete? Because concrete wall can prevent radioactive radiation from being released into the environment. Okay, and then the radioactive waste management site, it should be located away. Okay, it should be located away from residential areas and not at the city area where there is a vast population of humans. Okay, away from residential areas. And then the cooling agent, of course, it should be water and not air. Water and not air, because water has a high specific heat capacity and it is able to absorb a large amount of heat energy with a small increase in temperature. So as you can see here, based on our choices, so the best nuclear power station would be R. And you mention again your choices. Okay, so in the table form. Okay, this one, yeah. Location is by the sea because extensive water sources are needed as cooling agents. Okay, and then material for the building is a concrete because it can prevent radioactive radiation from being released into the environment. And then radioactive waste management site is away from residential area so that the public is safe from exposure to harmful radiation if there happens to be a leakage. And then the cooling agent is water because water have a high specific capacity and able to absorb a large amount of heat energy with a small increase in temperature. So your choice would be R. And then you mention again your choices because it is close to the sea, the wall of the building is concrete, the radioactive waste management site is far from the residential area, and the cooling agent is water. So all of this is 1 mark, and total would be 10 marks. Okay, 10 marks. Okay, next question. The next question would be number 3. The radioisotopes are used as radioactive source in paper industry. Okay, take note. This one is involving paper industry. So paper industry, so it will involve to measure the thickness of the paper. And then table 3 shows the characteristics of 5 radioisotopes material. So again, there are 4 characteristics given. So you have state of matter, emitted radiation, half-life, and also the penetrating power. So as a researcher, you are assigned to investigate the characteristics of a certain radioisotopes that could be used to detect the thickness of paper factory. Based on table 3, explain the suitable characteristics of a radioisotopes so that it can be used to measure the thickness of paper in a paper industry. Select the most suitable radioisotope to be used in detecting the thickness of paper in the factory and give your reason. Right? So firstly, the state of matter. All right. So we would choose the state of matter as solid. Okay, solid, because it is easier to handle compared to liquid or in gas form. Okay, and the next one, the emitted radiation that we should use is which one? So alpha is out. Alpha is out because alpha cannot penetrate through our skin. Moreover, it cannot penetrate through paper. So alpha is out. So it is either beta or gamma. Okay? Beta or gamma. And then, what is the reason? Here, we will be choosing beta. Actually, we will be choosing beta. Beta instead of gamma. Now, this is because beta particles, it still can penetrate through the paper, and it is less dangerous as compared to gamma rays. And then the half-life, it should be long. Okay, so again, you do not write the numbers as your choice, but you write down it is either long or short half-life. So in this case, we will be choosing long half-life. Okay, long half-life. The longest one would be 28 years. Okay, 28 years. This one in days, we will not choose. This one is too short. So it's either 28. Yeah, the longest would be 28 years, right? And then the penetrating power, it should be, we don't want it to be low. Because we don't want it to be low. We want it to be high. Or in this case, medium. Medium is also okay. Right? As long as it can penetrate to the paper. So if you choose medium, okay. So as you can see here, your choice would be strontium 90. Strontium 90. Okay. Okay, so we will refer to the table. Answer. Okay. Radioisotopes in solid form is suitable. Okay, solid form, easy to handle. Use beta particle. Beta particle can penetrate paper, less dangerous as compared to gamma rays. And the half-life would be long to ensure that it can be used for a longer period. And the fourth one is medium penetration power. It can penetrate paper. And your choice is strontium 90. And you write down your reason again. Solid emits beta particles, has a long half-life, and has a medium penetration power. Okay, so this one is 1 mark. All right, so that one is the sample of questions involving making decisions. Now we will go into questions on problem solving. Okay, problem solving involving nuclear physics. Okay, so example of questions is like this one. So diagram 1.1 shows a process that involves a uranium being hit by one neutron. Name the process as shown in diagram 1.1. So that process is either nuclear fusion or nuclear fission. So as you can see here, you will use one neutron and then it will bombard the target nucleus, and then it will split into two lighter nuclei and produce another 3 neutrons. So this is nuclear fission, right? Nuclear fission. Okay, and then diagram 1.2 shows an incomplete nuclear equation for the reaction or process as shown in diagram 1.1. So you complete the numbers so that it will be balanced on the left-hand side and on the right-hand side. So total would be, you can see here, the total for this one, 235 U plus with 1. This one is 236. Then this one, 92 plus 0, it will be equals to 92. And then after the arrow, all the numbers should add up like what is on the left-hand side. All right, so we have 92, and then this one, 3 times 1 is 3. So you should be able to calculate what is the missing number in the box. So you 236 you minus by 3, and then you minus by 92. So it should be 141. Okay, 236 you minus 92, and then you minus again with 3. So you will get 141. And then next is the one below. We have 56, and please do not do a wrong calculation here, because most of the students, sometimes they calculate this one, 3 times 0, it is equals to 3. So actually it is 0. 3 times 0 is 0. So 92, you minus by 56, minus again with 0. So total would be 36, right? 36. So only write your answer in the box. Your workings, you don't have to write. This one is 1 mark, this one is 1 mark. Okay. Right, next, question C. The worker who works in a nuclear plant noticed that he suffered hair loss, fatigue, and nausea. He suspected that the symptoms are caused by negative effect of radiation. Suggests the safety precautions that should be taken when handling radioactive materials. The suggestions are based on the following aspects: the equipment to be used in handling the radioactive source. So what do you think? The equipment to be used in handling the radioactive source, you should be using robotic hand. Okay, you can suggest to use robotic hand. You can suggest to use remote control through a glass LED screen, or you can also use forceps. Okay, and the reason is this is to avoid direct contact. okay, to avoid direct contact. And the second one, what are the safety precautions that can be applied by the worker? So the worker, he should wear plumbum coated uniform. Plumbum is also another name for lead. Okay. Or he can wear film badge and also disposable gloves. Okay. Okay. The reason is this is to avoid direct contact, or if he is wearing the film badge, this is to warn him of the level of exposure, or to inform permanent record of radiation dose received. Okay. If the film badge has turned black, means he has been exposed to a high dose of radiation. So he should get out from that place as soon as possible. Then number 3, the method of disposal of the radioactive waste. One of the method is to solidify in concrete. Solidified in concrete and buried underground. Buried underground. This is to avoid radiation from being released to the surrounding. Okay, right? So that is the suggestion that you can write if you get this type of questions, right? So we move on to the second question here. Okay, so this one, the diagram 2.1 shows the decay graph for uranium-235 in the nuclear reactor. Okay, and then use the graph in diagram 2.1 to estimate the half-life of uranium-235. So it wants you to estimate the half-life. Show clearly on the graph how you obtain your answer. So in order for us to determine the value of the half-life, so you look first the initial value. This is the initial value. Okay, so half of 100 is 50. Half of 100 is 50. So from there, okay, you use your ruler. This is the half-life. So you use your ruler and then do some interpolation. So this would be the value of your half-life, which is around 700 million, because the time is measured in million years. Okay, so each of the line indicates 200 million. So this one is in between 600 and also 800. So it is estimated as 700 million years. Right? So don't forget to write down the unit. This is the unit, million years. 700 million years. 700 million years, or you can also write in standard form It is 7 times 10 to the power of 8 years. All right. Okay, question B. If it is determined that a certain amount of stored uranium-235 will be considered safe only when its radioactivity has dropped to 0.1% of the original level, approximately how much time must the uranium-235 be stored securely to be safe? So in order for us to get this 0.1%, so we have to start from the initial value. The full value of percentage is 100%, right? Okay, so you start from 100% and then you divide by 2, divide by 2, divide by 2 until you get to 0.1%. Then you calculate how many half-life has it undergone through. Okay, so we will start with 100%. Since the full value of percentage is 100%. So you divide by 2. This is 1 half-life. Half of 100% is 50%. Okay, and then another half-life. Half of 50% is 25%. Okay, so you continue to divide by 2. 12.5%. Then another one is around 6.3%. Then 3.2%. Then another half-life is 1.6%. Okay, and then another half-life 0.8%. Another half-life 0.4%. 0.2%, and then finally is 0.1%. Okay, and then you calculate how many half-life. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there are 10 half-life. So 10 half-life is equals to, because 1 half-life is equals to 700 million years, so you just have to multiply with that number. Okay, 10. Okay, so it is equals to 7 times 10 to the power of 9 years. Right, so this is the answer. Okay. Okay, next one, C. Diagram 2.2 shows a system used to detect cracks in concrete walls. And then a company uses this system to detect cracks in the walls of the buildings. Various types of radioisotopes can be chosen, but the company have to select the appropriate radioisotopes for the purpose of cost saving and efficiency. Suggest the most suitable radioisotope, and proposal is based on the following aspect. Okay, so the type of radiation that is suitable to detect cracks, it would be alpha is out, beta is okay, but judging from this one, it would be better if we use gamma. Okay, gamma. So it's either you use beta or gamma. So gamma radiation, reason is because high penetrating power. Because this one involves concrete, so you should use a higher penetrating power, which is gamma, instead of beta. High penetrating power. Next one, half-life. Of course, we want long half-life. Long half-life, reason is It's either you write down safe cost or it can be used for a long time. Can be used for a long time. And the physical state, it would be solid, easy to handle, or won't spill. Okay, won't spill. All right. Okay, so let's move on to section B and C. Section B and C. Okay, diagram 1 shows a nuclear power station in Fukushima, Japan. The station was hit by a disaster during the tsunami in 2011. Good safety aspects in the power station can reduce the adverse effects of the disaster. Now, Malaysia plans to build a better nuclear power station. As a scientist, you are required to suggest the appropriate aspects to build it. State and explain the modification based on aspect, such as the location of the nuclear power plants. So again, you can highlight this one. Location of the nuclear power plants. This one is aspect number 1. Second one is walls of core. Okay, walls of core, and there is a, it is connected by the word and. So actually it is two aspects here. Okay, walls of core is number 2, and then walls of reactor buildings. Okay, this one is also walls of reactor buildings, number 3. Number 4 is the cooling agents. And number 5 is the radioactive waste management. Okay, so you have 5 aspects and 5 suggestions for you to get 10 marks. Right? So again, for this essay question, please answer in table form. Okay, please answer in table form. Now I will show you the sample of suggested answers. Okay. Okay. The location. Firstly, the location, it should be by the sea. Okay, it should be by the sea. By the sea or close to abundant natural water resources. This is because we will be using the water resources as the cooling agent, right? It will be used as cooling agents. Now, the second aspect is the reactor core wall. It should be made from thick plumbum. Okay, thick plumbum or lead. Plumbum or lead lah. Another name for plumbum is also lead, and it has to be thick. The reason is because this is to prevent radioactive radiation from being released into the environment or to prevent leakage. The third aspect is the walls of the reactor buildings. Okay, this one is made from thick concrete. Okay, this one is building. The previous one is the core wall. Core wall, it is made from thick lead or plumbum, and the reactor building, it is made from thick concrete. This is to prevent radioactive radiation from being released into the environment or to prevent leakage. And then the coolant. Coolant, of course, we will be using water. Water, because water have a high specific heat capacity, and also it can absorb a large amount of heat energy with a small increase in temperature. And the last one is the radioactive waste, material waste management. Okay, so you should be, you should suggest here to build a disposal facility site and storage. Okay, and reason is waste of radioactive material can be stored at the site of disposal facilities and storage at a safe depth. Okay, so that is how you suggest, and then you can get 10 marks, right? You can get 10 marks. Okay, so let's look at the next question. Diagram 2 shows a nuclear reactor. Nuclear reactor. So you are required to give some suggestions to design a nuclear reactor that can safely generate more electricity during the daytime. Safely generate more electricity during the daytime. State and explain the suggestions based on the following aspect. So your aspect, okay, you are given 4 aspects here and then 10 marks. So means that one of the aspect you can give more than one suggestion so that you will get 10 marks, right? The position and type of control rod, the material used to construct the pressure vessel, the type of gas used as a cooling agent, and the shape of heating exchanger pipe, right? So answer in table form. Now I will show you the suggested answer. Okay. Take note that this one is actually 2. One is position and the other one is type. So overall, there will be 5 aspects. Each one you can give one suggestion and also explanation. Now the position. Position. Okay. This one. The control rod. Position of the control rod, it should be high. Okay. The control rod should be high. This is to absorb less neutron and releases more energy. Then the type of control rod, it is made from boron. So it's either boron or cadmium. You can also write down here, it can also use cadmium. This is to absorb neutrons. And then the pressure vessel. The pressure vessel should be made from steel because it is strong and can withstand high pressure, or you can also say that it does not rust easily. Rate of rusting is low. Okay. For the cooling agent, gas as a cooling agent, you should use carbon dioxide. Carbon dioxide as a cooling agent, okay, because it wants you to suggest in the form of gas and not liquid. Previously, we would mention water as a cooling agent, but since it asked you about gas, so you should write carbon dioxide as the cooling agent. This is because it has high specific heat capacity. And the pipes should be long pipes, or you can also suggest the pipes installed in loops to save space. This is to increase the surface area and also to enable water absorb more heat. Okay, so overall you will get 10 marks for this. Okay, 10 marks for that. Okay, moving on to the second last question. Okay, this one is number 3. Diagram 3 shows an experiment to study the intake of chemicals by plants. How would you choose the radioisotope and the type of detector to be used in the experiment? In your answers, consider the following aspects and give your reason. So you are given 4 aspects here. Actually, there are 5. Half-life of the radioisotope. This is one half-life. the phase of radioisotope, either solid, liquid, or gas, the type of radiation, alpha, beta, or gamma, and then this one, size and mass. So there are two aspects here: size of detector and also mass of detector. So 5 aspects. So the half-life, okay, because this is an experiment and we want the half-life to be short. We do not want the half-life to be long, because if you answer the half-life as long half-life, so it will take you quite a long time to get the results of your experiment. Okay, so bear in mind that the usage of long half-life and short half-life varies according to the situations given. So in this case, because you are doing some experiments, then it would be better if you use a short half-life. Okay, short half-life, it should be in a few days. Reason is so that there is still sufficient activity available to be measured during the course of the investigation, and the negative effects will be minimized as the half-life is not too long, right? Because you are doing an experiment to study the intake of chemicals by plants. So the radioisotope that you will be using, it should have a short half-life. Okay, should have a short half-life so that you won't be exposed too much on the radiation. Okay, and then the next one, the phase of radioisotope. Because this one is involving plants, so it would be better if we use in liquid form, instead of solid or gas, because in liquid form, it can be easily absorbed by the plant. Okay, in liquid form, it can be easily absorbed by the plant. Okay, the third one, type of radiation, it is either beta or gamma. Beta or gamma. Alpha is out because it cannot penetrate through the leaves or the plants. So it is either beta particles or gamma radiation. Reason is because the radiation can penetrate the plant and be measured from outside. Okay, and the size of the detector, it should be small. Okay, it should be small and lightweight. Reason is high mobility and easy to handle. And then the last one is type of detector, type of radiation emitted by the radioisotope. So the detector would be Geiger-Müller counter. Reason, it can detect the radiation emitted and count the activity of the radiation quickly. Okay, so I will show you the suggested answer. Okay, right, this one. This is the suggested answer. The half-life should be short or a few days. Okay, so this is the reason. Radioisotope in liquid phase, easily absorbed by the plant. Okay, then it should emit either beta particles or gamma radiation, so that it can penetrate the plant and be measured from outside. The detector used is Geiger-Müller counter, or you can also write as GM counter. It can detect the radiation emitted and count the activity of the radiation quickly. And in terms of size and mass, it should be small size and lightweight because of the high mobility and easy to handle. Okay. Okay, so for the last question, Okay, so it will be this one. Question number 4. A liquid detergent producing factory is equipped with a volume control system to ensure the amount of liquid detergent in a bottle is within specified range. The bottles of liquid detergent are transported on a conveyor belt, as shown in diagram 4. If the volume of liquid less than or more than the specified range of volume, the bottle will be removed automatically. Okay. Using your knowledge on radioactivity and diagram 4, explain how the equipment is set up, the choice of radioactive substance used for volume control, and how the system works. All right, so because this one is to detect the volume, so it would be better if we use beta rays instead of gamma rays, because gamma rays is quite dangerous if you are exposed to it. So better to use beta radiation. It can still penetrate through. Right, so I will show you the suggested answer based on the aspect. Okay. GM tube is used as a radioactive detector. GM tube is used as a radioactive detector because reason is it can detect beta rays. Then bottle passes through between the radioactive source and the detector. So you should install the radioactive source and the detector so that the correct volume of the detergent can be determined. Means that you can put, this is the location or position of the radioactive source. This is the radioactive source. And exactly above it, okay, exactly above it is the detector. So this is the detector. GM tube detector. So when the bottles pass through, in between the radioactive source and the GM tube detector, so it will be able to trace whether it is, if the volume is more than or less than the specified range of volume. Okay, so hold on, do some correction here. So the radioactive source, because this one is vertical, so the detector should be placed opposite it. Okay, so this is the radioactive source. This is the detector, GM tube detector. So it should be placed opposite with each other. So when the bottles pass through in between the radioactive source and the GM tube detector, so it will be able to detect whether the level is more than or less than the specified range of volume. If like this one, it is less, then it will be eliminated. It will be taken out and the detector will beep. Dia akan berbunyi lah. If the volume is exactly within the specified range of volume, then it will go through the conveyor belt until the end. Sometimes maybe it is more, less, or ngam-ngam. So that is the function of the radioactive source and the GM tube detector. Okay. Next is Solid radioactive material is chosen. Okay, solid. Solid radioactive material is chosen because it can be easily handled. Radioactive rays have medium penetrating power. Medium penetrating power, so it won't be easily stopped. Radioactive material has a long half-life so that it can be used for a longer time. Save costs. GM tube is connected to a logic gate system. All right, this is what I told you just now. The GM tube is connected to a logic gate system. The reading of the rate meter is calibrated with the volume of the detergent. If the reading is within range, it will be accepted. If the reading is beyond or less than the range, it will be rejected. Right? So that is how you suggest your answer for this situation. Right? So I have finished discussing this sample of questions. And so if you have any questions regarding this, you can always ask me. All right. So I think that's all. Thank you.